Mole concept tricks and important questions. In an organic compound containing C, H, and N gave the following analysis: C is 40%, H is 13.33%, N is 46.67%. Its empirical formula is, you will try to solve this question, but there is a trick for this question. The trick is that you have to find mass percent of the elements from all options. That is, if in option 1 C, mass of C is equal to 12 upon 30, that is total molar mass, into 100, which is equal to 40%. So 40% here matches to the data given in the question, and the question is solved just in one or two line applying this trick. And अगर मास ऑफ दो कंपाउंड सेम आ जाता है तो फिर आप किसी और एलिमेंट का भी कर सकते हैं। जैसे अगर इसका 40% आ गया और इसका भी 40% आ गया, तो दूसरे एलिमेंट कर ट्राई करके भी खोज सकते हैं, जिसका मिल गया वो आ गया। A compounder in a compound ratio of mass of its elements is C is to S is to nitrogen is 9 is to 1 is to 3.5. If molecular mass is 100, find the molecular formula. The question is that here we have the ratio. What a person would do is, first of all he would take the mass, and then he would divide by the atomic masses of all these three elements, and then it would add, and then it will be very difficult. The simple solution is just apply x all these three times and add it, and which equated to 108. You will get the value of x, and multiply it with all the three, and you will get the weights of all these three elements. Then you can calculate the moles by dividing their respective molar masses, and you can get the empirical formula. 50 kg of nitrogen and 10 kg of hydrogen are mixed to produce NH3. Calculate the moles of NH3 formed. Identify the limiting reagent. Okay, so how people solve is this: first they try to calculate the number of moles, which is you calculate, and then you also try to find the mole ratio. And once you find the limiting reagent, then you try to solve it like this: 3 moles of H2 give 2 NH3 moles, and then 1 mole of would give 2 by 3, then 5 into this. Okay, it is a long process. So just try to divide the number of moles of any element by its stoichiometric coefficient on both the side, and then equate. It is time saving. And then next question: liquid benzene burns an oxygen according to this formula. How many liters of oxygen STP are needed to complete the combustion of 39 gram liquid benzene? It is very simple question. Weight of liquid benzene is given, so moles will be calculated. Now we have to just equate the two moles. For example, half mole is the original mole given, 2 mole give this, so half would give 15 by 4. Now this would be the mole of oxygen actually according to this question, 15 by 4 that is, and then 15 by 4 into 22.4 liter equals 84 liter. It is a simple question, but it cannot be solved because most of the questions are like going to the products and then to the reactants, and then this is just simple but easily forgettable. Okay, 1 mole of KClO3 is thermally decomposed and excess of aluminum is burnt in the gaseous product. How many moles? Here the main thing is to write the two reactions very correctly. When you write the first reaction, you get that here 2 mole, but in question it is given 1 mole. So and 2 mole in the actual reaction gives 3 mole of oxygen, so 1 mole would 3 by 2 mole. Similarly, in the second reaction, 3 mole gives 3 mole oxygen, that is common in these two reactions, gives 2 mole of the product. So 3 gives 2, so 3 by 2 would give 2 upon 3 and 2 3 by 2, that is 1 mole. Easy but easily forgettable. Next question: 1 liter of CO2 is passed through red hot coke. The volume becomes 1.4 liter at the same temperature and pressure. The composition of products is. Very difficult question, especially just wrote learn this question. It can be solved. So here is the first reaction. It is CO2 plus coke, that is simple carbon. gives carbon monoxide. So balance it, and then you have that 1 liter of CO2 is present. So let x out of 1 of CO2 be used, and then the left would be 1 minus x liters. If 1 liter is given in the question and x be used, then left would be 1 minus x. So the volume that remains after the reaction would also include this 1 minus x, because not all 1 liter would be used. So this would account for liter because it would be liquid. This would be left, and the used one would later change into solid or something else. Now liters of carbon monoxide, if you try to find, then you see here 1 mole and then here 2 mole, and some with the same with the volume, equal temperature and pressure, same volumes. So you will have 1 liter then 2 liter here, which is equal to 2x, because not whole 1 liter is applied, a part of it, that is x liter, is applied used, so it would be 2x. Now according to question, the whole residue left after the reaction amounts to 1.4 liters, that is 1 minus x, that is the left CO2, and then the CO that was formed by the CO2 x liter, okay, which was used up for it. Sum it equals to 1.4, you get x equals to 0.4. Now CO2 left was 1 minus x as said, so 0.6, and then CO2 produced was 2x, so option number 3. Change in volume when 100 ml PH3 decomposes to solid phosphorus and hydrogen gas. Simple question, but still easily forgettable. Now 4pH3 equals to P4 plus 6H2. Simple reaction. It is given that it is 100 ml. So 4 gives. We know that P4 is gonna be solid because P4 is phosphorus and it will be solid, and H2 will be gas. It is not mentioned, but still here it is H2 gas. So to solid phosphorus and H2 gas, so you can realize that. So it means that all the ml or liter or any liquid or volume thing is maintained in this thing, not this. Okay, so simply 4 mole of pH3 gives 6 mole of H2, so 1 would be 6 by 4, 1.5, 100 would be 150 ml, so increase would be 50 ml. Option number 1. Percentage of this question is very important, because not in the percentage of as a tough question, but as a time saving question. Here in the question we have SC, that is just not to be read by students of our class. We don't have to read SC at all. In peroxidase anhydrous enzyme is 0.5% by weight, atomic weight is given. Then minimum molecular weight of peroxidase anhydrous enzyme is, it is just simple question. We have been said that itna percent of some high-fi chemical weighs is this, because you cannot break an atom. Okay, the minimum weight of anything would be of any element would be its atom. Okay, so here it is 78.4, and it is said that 0.5% of that element is equal to 78.4. Just the same thing, then x would be this. Calculating it would be easy, very easy, but still it should be remembered. And you should not go on this name, peroxidase anhydrous enzyme, peroxidase anhydrous enzyme. It is just a way to distract the students to think, so that they think that it is